In this video, we're going to be going over set theory basics and expanding on the symbols and vocabulary from the previous video. First word is subset. The set A is a subset of set B if every element in set A is also an element in set B. We'd write this by just saying A is a subset of B. So that little C with a line underneath it represents subset. An example of this, H. The set H is the set of all elements X such that X is a human, and the set J is the set of all elements Y such that Y is a human aged 15 to 30 years old. So clearly J is a little smaller than H, and it is a subset of H because all humans aged 15 to 30 are in the set of all humans. But if we looked at the other way around, H is not a subset of J because there are humans outside the age range that won't fall in it. Proper subset. The set A is a proper subset of set B if set A is a subset of set B and sets A and B are not equal. This is denoted by A, and then similar to the last subset symbol, but there's no line underneath the little C there. So that would say A is a proper subset of B. In a little example here, D is equal to the 1, 3. The set E is 1, 3, 5, and F is 3, 5, 1. D, we could say, is a subset of E. D is also a proper subset of E. D is a subset of F because all the elements in D are contained in E and F, and neither of them are equal to D. Oh, that's going to be proper subset. D is a proper subset of F because all the elements are contained in F and it is not equal. But looking at E, so E is a subset of F, but E is not a proper subset of F because they are equal. F is a subset of E, but F is not a proper subset of E. Once again, because they are equal. Just because they're in a little different order here doesn't mean that there's no distinct there's still 3 distinct elements there. That's all that really matters. You could rearrange those. That's why I just wanted to throw that in as an example to show it to everybody. If a set contains n elements, there exists 2 to the n total possible subsets. So if A is equal to 0, 1, 2 here, we're going to use the equation 2 to the n. So that'll give us the number of total possible subsets. Cardinality of A here is 3. So in our case, 2 to the third is equal to 8 possible subsets, or total subsets. So if you look at them all here, it's called a superset. All the subsets that are contained in A. So 0, if you had a set that just had 0 in it, that would be contained. Set 1 is a subset. 2, 0, 2, 1, 2. The set itself is a subset of itself. So 0, 1, 2 there. And if you look at it right now, we have 7 sets. One thing to note is that the empty set is actually included in the span of all the subsets because the empty set is a subset of A. And we'll close that off with some more red brackets over here. If a set contains n elements, there exists 2 to the n minus 1 total possible proper subsets. So 2 to the n minus 1 proper subsets, which makes sense if we look back to our definition from the last page here. A and B are not equal. That's pretty much the difference between a proper subset and a subset. They cannot be equal to each other. So that's just going to remove the set that equals itself right here. That's where we get that 2 to the n minus 1. So 2 to the third minus 1 is equal to 7 proper subsets are contained in A. Universal set, the set U containing all elements under discussion. So this is represented by this U here. It kind of gives us a background drop just for setting up sets and Venn diagrams. So A and B might be country singers, B might be pop singers, and the universal set might be all singers. So it just kind of establishes that nice background and gives us some relevance for where our sets are in. Disjoint sets. Two sets are disjoint if they have no elements in common. So in this case, they have 0 elements in common as represented by this Venn diagram here. And our universal set is still in the background. These might be, like A might be dogs and B might be cats, and the universal set in the background might be all animals. So just kind of relative. This can also apply to sets that just involve numbers and stuff. It doesn't, I'm just kind of giving real life examples because they're a little easier to visualize. Complement, the set of all elements in the universal set that are not contained in the specified set. The complement of set A is denoted A prime and orally pronounced A complement. So in this case, if we wanted to call this circle here A, if we wanted to look at A complement, here I'll actually make it a different color here. Let's look at A complement. It would be all this background noise right here, which we would, so pretty much everything and anything in the universal set in the background there. Intersection. The intersection of two sets, A and B, is the set of elements contained in both set A and set B. So intersection, a lot of times I just think of the word and. What it is, so if this was A and this was B, back to our, if A was country singers and B was pop singers, there exists this genre of people that are country and pop. For example, Taylor Swift would fall in there. And yeah, the background would still be the set of all singers, and just kind of explain that the intersection here is the ones that are contained in both. Now the union of two sets, A and B, is the set of all elements that are members of set A or B, or of both sets. So in this case, the union of A and B, it includes all elements in A or B or both. So every single one of these is included in the union. And then the universal set is still obviously in the background there. But that sums it up for this video. Thanks for watching.